Video, we're going to start diving into the law of sines and the law of cosine. So let's start with just the concepts of law of sines and law of cosines. So the law of sines and the law of cosines allows you to apply trigonometric functions to non-right triangles. So up to this point we've been doing right triangles. Now we're going to look at non-right triangles. So we will be given a triangle. Let's see. Do I have a tool? No, I'm just going to use this tool. So we're given a triangle. And again, I apologize for my lines. I have to use this tool because you all have seen my lines. You all have seen my lines without using some type of straight edge. And so I'm going to use a straight edge, and yes, I know I should plan ahead and I should have drawn this triangle first, but I did not. So here we go. There you go. Bam. There is a triangle, and this triangle has angles A, B, and C, and leg A, B. I did that backwards. Sorry, A is opposite the other side of A, B is opposite B, and C is opposite C. Alright, so we're given a triangle A, B, and C, and the angles A, B, and C are opposite sides of the length A, B, and C. The law of sine states, and this is the law of sines, states that side of A, so sine of angle A divided by leg A is equal to sine of angle B divided by B. So basically the ratio of sine of the angle divided by the length of the angle will equal the same ratio as sine of angle C divided by leg C. Alright, so that's the law of sines. The law of cosines. Let me grab a different color so I can write the law of cosines. So the law of cosines is basically a squared plus b. Oh, sorry. A squared equals b squared plus c squared. So we have Pythagoras theorem minus 2bc times the cosine of angle A. And that's if we want to find, let's say we do want to find the length of side A. Now let's say we want to find the length of side B. This would be b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Let's say I want to find the length of C. Then this would be a squared plus b squared minus 2ab cosine of angle C. All right, and this is looking at an ABC triangle. Now let's put this into practicalities. Let's do an example here. And by the way, if you want to look at the proof, the enVision Algebra 2 math book, example 1, will show the proof of law of sines. But here we're just going to jump straight into an example. We have a story problem, and I'll read the story problem. I did not write it out this time. But in this problem, Nicholas is walking along an obstacle course that begins at point X. So we have point X down here, and he starts going straight on the path. It takes a wide right turn onto the second path at point Y and continues for 1,000 feet. So what we're looking at here is I'm going to do kind of connect the dots. connecting the dots as much as I can. Right there. And then it says we take a sharp right turn here. And again, it's always great to draw these pictures out as you read through the models. Right turn. And then because we are dealing with triangles, I'm just going to connect this up. Okay, this triangle is not drawn to scale, but it's just the best that I can do. Okay, so he starts going straight on the path. It then takes a wide right turn onto the second path at point Y and continues for 1,000 feet. So this goes for 1,000 feet. I don't know, I just put an F and not a T. There we go. Before turning onto the final path at point Z. So this is point Z right here. What is the angle between the second path and the final path? They have a drawing and they say that this length between X and Y is 1,200 feet. Okay, they also give us this angle of 32 degrees. And they want to know what is the angle between the second path and the final path, point Z, round to the nearest tenth. So I'm going to use this one, and this is what they want to know. All right, so thinking of the law of sines, this is going to be little x. No, that's not little x. Sorry. This is little x, this is little y, and this is little z. Okay, so now looking at the law of sines, I think I'm going to do, I know sine of x, because I do know this value would be divided by x equals sine of z. This is the angle that I want to know over z. All right, so what I'm going to do here is I'm going to use substitution. And I'm going to substitute my values in. So I see here that sine of x, x is 32, so sine of 32 degrees divided by my x value, which is 1,000 feet, equals sine of z, we don't know what z is, divided by 1,200 feet. All right, so just basically following through with this. This is going to be times 1,200 times 1,200. Those will cancel out. I'm left with 6 because that simplifies to 6/5. Sine of 32 degrees divided by 5 equals sine of angle Z. All right, so now I want z to be on its own, so I'm going to undo the function by taking the inverse sine, the inverse of sine. So I get here roughly the angle of z is equal to 39, roughly equal to 39.5 degrees. All right, and between these two steps I used a calculator just to solve for that. All right, so since the turn at angle y is described as wide, angle y must be obtuse. So this is an obtuse, which means that angle z is an acute. And this means that we don't actually have to check the other angles since our value was less than 90 degrees, so it's an acute. So I'd say that the angle between the second path and the trail is 39.5 degrees, or that angle z is 39.5 degrees. All right, let's look at another example. Amaya is flying a Zeppelin balloon. The string is 90 feet long. So I'm going to take a pause And I'm going to drop my string to the Zeppelin balloon. Alright, so I know that this is 90 feet. And the angle of elevation to the balloon from the ground, so that's a little missing. We're looking at the angle of elevation to the balloon from the ground. So let me draw the ground here. Try to do that as a 0. This angle right here is going to be 60 degrees. Across the park, Rochelle is watching the balloon, which is between Rochelle and Amaya. So let's get Rochelle is standing there, and the balloon is just between them, not right above Rochelle, just a little bit kind of between the two. So I'm just going to try to do it like this. I mean, it's kind of closer to Rochelle in my picture, but again, this is not drawn to scale. So here's Amaya, my lovely stick figures. Here's Rochelle. She's watching the balloon. All right. The angle of elevation from Rochelle's feet to the balloon is 75 degrees. So this angle right here is 75 degrees. How far apart are Amaya and Rochelle standing round to the nearest foot? So we want to know this distance right here. How far apart are they standing? Okay, so let's see what we have here. I'm going to call this R for Rochelle. Oh, sorry. I hit a button on the side of my pen and now it's going crazy. Okay, there we go. I'm going to call this R for Rochelle, A for Amaya. Okay, so I'm going to say that sine of Rochelle, this is little r, equals sine of A. This is little a. Well, looking at this, we really want to know, and this is the balloon. And I'm going to call this Z for Zeppelin. So what we really want to do is we do actually want to find sine of Z. And then this is little z. So sine of A, little a. I like how to make that a big A. That's just to be a little a. And then sine of Z is going to be over little z. So really what I want is this guy to be part of my equation. That's a z, not an e. So let me erase that, make it look more like a z. There we go. And then again I hit the little side of my pen. All right. So what I do need to do is I have enough information to find this Zeppelin's angle. So I'm going to take 180 degrees. So 180, subtract 75, and subtract 60. And from this I get 45 degrees. So this piece is 45 degrees. So now I do know sine of 45 over z, which is the distance between Rochelle and Amaya, is equal to, well, I know this 90 degrees and I know this 75, so I'm going to say sine of r divided by r. I guess I could have substituted those in right away. I didn't. I did it here, but I didn't do it here. So this is sine of 45 divided by z equals sine of 70 divided by 90. All right, so z is in the denominator here, so everything has to be the reciprocal for me to solve for z. So we're looking at sine of, see, 90, that's reciprocal, sine of 45. Oh, I put 70 instead of 75, sorry guys. Divided by sine of 75. Alright, so I'm going to use a handy dandy calculator. The side z, which is this guy right here, is going to equal roughly 65 0.9 feet. We need to round to the nearest foot, so that's going to be the 10th of a foot, so it's going to be 65.9 feet. So Maya, and Rochelle are 65.9 feet apart. Alright guys, so this is the end of the use of the law of sines. In the next video we'll be looking at the law of cosines and give some examples for that. Always, please ask any questions, comments, concerns, and I will see you in the next video.